Welcome to another exciting educational video brought to you by Up Vision Concepts Academy. So today we'll be looking at IGCSE Maths, and we'll be talking about sequences, finding nth-term arithmetic and geometric progression. So in today's class, please sit tight. If you're not yet subscribed to our channel, kindly subscribe to our channel to get more of our content. Okay, so we dive in. So by the end of this lesson, you should be able to recognize different types of number sequences, identify whether a sequence is arithmetic, geometric, or neither. Find the nth term of an arithmetic sequence, the nth term of a geometric sequence, the nth term of formula to calculate any term, then solve IGCSE-style problems requiring reasoning about patterns and formula. All right, so a sequence is an ordered list of numbers following a pattern. Examples of sequence includes 3, 7, 11, 15, and so on. So there's a pattern. They started with 3, and between 3 and 7, the next number is a 4. I can see that the difference is a 4, and if I add 4 to 7, I will get 11. If I add 4 to 11, I will get 15, and so on. So there's an order. So a sequence is an ordered list of numbers following a pattern. So there's a pattern. Okay, there's something that's the number that starts it, and this number is called the first term, and the second number is the second term. The third number is the third term. The fourth number is the fourth term, and so on and so forth. So if we don't know a particular a number in the n series, you can call it the nth term. Okay, so it follows a particular order. Another form of sequence can include 5, 10, 20, 40, and so on. So this is another sequence, though the order is as if it is increasing by multiplication by 2. If I have 5, if I say 5 times 2, I'll get 10. I have 10, if I say 10 times 2, I get 20. I have 20, if I say 20 times 2, I get 40, and so on. So the next one is 1, 1, 2, 3, and 5. Now this one might not have an order that is following, but there might be a formula that we can use to get it. So we rely on the nth term formula to find any term without writing the whole sequence. So we rely on the nth term formula. All right. So there are two main types for IGSE. Two main types of sequence. So there are two main types for IGCSE. Okay, so the first one is the arithmetic sequence, and the second one is the geometric sequence. Okay, now the arithmetic sequence is a sequence where the term increases or decreases by the same amount each time. So I'll say the arithmetic sequence is the sequence where terms increase or decrease by the same amount each time. Okay, for example, if I have 2, next term is 5, next term is 8, next term is 11, then so on and so forth. Now, like I said in the previous discussion, 2 is the first term, right? The first number is the first term. Second number is the second term. Third number is the third term. Fourth number is the fourth term, and so on. So arithmetic sequence is the sequence where the terms increase. Each term increase or decrease by the same amount each time. So between first and second in this case, the amount of increase is 3. Between 5 and 8, the amount of increase is 3. Between 8 and 11, the amount of increase is 3 because 5 minus 2 is 3, 8 minus 5 is 3, and 11 minus 8 is 3. So who can tell me the next one am I expecting here? What do? I just add 3 to this, and I will get 14, and so on and so forth. So that is the increase. So that's this constant 3, 3, 3, 3 that we have here. We call them, or we call it common difference. Common difference. Common difference is noted by the symbol D. So gradually we'll begin to get a formula for arithmetic sequence. If common difference is 3, common difference means this number that is constant separating the two terms. First term is equals to A. So this number that is starting this sequence always is known as its first term, is A. Okay, so the formula for the nth term is equals to nth term formula. Let me put it here, nth term formula. Nth term formula is equals to, or I will say an is equals to A plus open bracket n minus 1, then close bracket D. So this is the formula to find the nth term of an arithmetic progression. First of all, you have to inspect the progression to understand that this progression is arithmetic. The condition is that each term is increasing by a constant amount. So each term is increasing by a constant. So if I have 2 here and I add 3 to 2, I get 5. I add 3 to 5, I get 8. I add 3 to 8, I get 11. I add 3 to 11, I get 14, and so on. So if we can identify that this is an arithmetic progression by this kind of characteristics, I can use this formula to find the nth term. Now this formula, I said that A is the first term, N is the number of terms, and D is the common difference. So now with this sequence that I have here, who can tell me the, this is 1, 2, 3, 4, 5, yes? Who can tell me the seventh term? To get the seventh term, I will say A is 2, A is the first term, 2, N, the nth term, that is 7, and D, common difference, is 3. So if I put these things in this formula, I will get that seventh term. The seventh term here is, I put A here, A is 2, plus open bracket, N is 7, minus 1, then close bracket, then D is 3. Okay, so 7 minus 1 is 4. 7 minus 1 is 4. 4 times 3 is 12. 12 plus 2. Sorry, 7 minus 1 is not 4. 7 minus 1 is 6, right? 7 minus 1 is 6. Okay, let me put it up here. 7 minus 1 is 6, right? Times 3 and plus 2, right? This is, I'm just trying to solve this here. 7 minus 1 is 6. 6 times 3 is 18. 18 plus 2 is 20. All right, so 20 is the answer. 20 is the seventh term. We can also count it. I have 14 here, right? This is 1, 2, 3, 4, 5 term. Then the sixth term is 14 plus 3 is 17. And the seventh term is 3 plus 17 is 20. So this formula is correct for finding the arithmetic progression. All right, so the next one is geometric sequence. So geometric sequence is a sequence where each term is multiplied by the same number every time. So it's a sequence where each term is multiplied by the same number each time. Okay. So example, if I have this sequence 3, 6, 12, 24, and so on and so forth. Now you see that there is a common ratio that if I divide 6 by 3, I get 2. I divide 12 by 6, I get 2 again. I divide 24 by 12, I get 2. So what will I do to get this other term? If I put a 2 here, that means I'm going to multiply 2 by 24 to get 48, such that if I divide 48 by 2, I get 24. So you see that the characteristics of the geometric progression is that each term is multiplied by the same number. This same number that we are multiplying each term is known as the common ratio. The common ratio R. Common ratio R is 2 for this particular case. All right, so for the formula of nth term for the geometric sequence, an is equals to a dot r raised to the power n minus 1, where an, this one, is the nth term, a is the first term, r is the common ratio, and n is the number of terms. Okay, so now we'll look at a way to do this. If, for instance, I am asked to now find this is first term, second term, third term, fourth term, fifth term. There's a sixth term that we don't know, question mark, seventh term that we don't know, question mark. So I want to skip sixth term, I want to find seventh term. I might not have to write everything, but I use this formula to get the answer. So if I want to get the answer for the seventh term, I will say A7, which is seventh term, is equals to A raised to the power, A times R raised to the power n minus 1, where A in this case is 6, A in this case is 3, R in this case is 2, and N, because we're looking for seventh term, is 7. So I'll just put all this inside this formula. So A7 is equals to A is 3 times R is 2 raised to power 7 minus 1. So A7 is equals to 3 times 7 minus 1 is 6. So 3 raised to power 6. So I'm going to multiply 2 in 6 places to get this one and multiply by 3. So let's do that and get the answer. So A7 is equals to 3 times 64. 3 times 64 will now give us, let's do the maths together, 192. So 192 is the seventh term of this particular sequence. So if you multiply this by 2, for instance, and this by 2, for instance, you get to this point. All right. So we're going to find the nth term of this sequence. Find the nth term. Find the nth term of 7, 12, 17, 22, and so on. Okay, from here, let's know what kind of sequence is this. Is it arithmetic or geometric? So we're going to test whether the difference between these two and these two, you understand? Is it a difference or a that's the difference? Is it you subtract the preceding term by the succeeding term, or you divide by a constant number? If you are subtracting the preceding term from the term that is coming before it, if you are subtracting and get a constant number, that sequence is known as arithmetic progression. For instance, 12 minus 7 is 5, right? And 17 minus 12 is also 5. Then 22 minus 12 is 5. So this makes it an arithmetic progression. So therefore, the nth term, an, of this progression is a plus n minus 1, then d. And a in this situation is 7. N is Cn, because we don't know what n is the nth term. Then d is 5. So this is the formula for the nth term. I can also open it up or expand. I would say 7 plus 5 times n is 5n, and 5 times 1 is minus 5. All right? So I collect like terms. So 7 minus 5 plus 5n. Why? Because this and this are like terms. They are numbers. So by the time I do the maths, 5 minus 7 is 2 plus 5n. So this is the formula, the nth term of that particular sequence. A to 7 is equals to 2 plus 5n. That is the nth term of that sequence. Okay? So we are to look at this example, example 2, where we are considering the nth term of a decreasing arithmetic sequence. So this is an arithmetic sequence that is decreasing. Why? Because from the first term, which is the highest, I go to the next term, which is lower than the first term. I go to the third term lower than the second term. I go to the fifth term fourth term lower than the third term. So you see that this is a decreasing sequence. You understand? The common ratio or common difference for this is going to be a negative. Okay, so for this one, first term, which is A, is equals to 20. Common difference, which is D, is equals to be 15 minus 20, which will give us minus 5. Anyhow you want to see it, if you want to say 10 minus 15, just do the difference between two consecutive terms. So I'm taking first and second term. First and second term, 15 minus 20 is minus 5. 10 minus 15, still minus 5. 5 minus 10, still minus 5. Any one you are taking, it will still give you minus 5. So that minus 5 is the common difference. And this minus 5 is telling us that, this minus is telling us that this arithmetic progression is, arithmetic sequence is decreasing. All right? So to get the nth term formula for this is A plus n minus 1, then D. That is open bracket and close bracket. Okay, so the first term in this particular case is 20 plus common difference, number of term is unknown, then common difference is minus 5 outside, all right? So I will do the algebra, just expand 20 plus minus 5 times n is minus 5. Let me put the minus 5 here, minus 5n, right? The minus 5 times minus 1 is plus 5. Okay, so collecting like terms, I have 20 plus 5 minus 5n, all is equals to an. And an is equals to 20 plus 5 is 25 minus 5n. So an can be expressed as, I can even do a factoring, 5 outside, 5 inside, 1n. So this looks like it's in factor form. Okay? Or I can leave it like this. I can leave it like this, depending on what your option is carrying. Okay. So we are to find the nth term of a geometric sequence. This is a geometric sequence. How do I know it's a geometric sequence? It's because if I divide this preceding term, that's this subsequent term, by the preceding term, I'll get a constant number. So 12 divided by 4 is 3. 36 divided by 12 is 3. 188 divided by 36 is also 3. So this constant number I'm getting, which is known as the common difference for this particular case, is known as the geometric sequence. Now, to get the nth term for geometric sequence, where A is equals to, okay, let me call it A1. A1 is the first term, it's equals to 4. And R, common difference, is 12 divided by 4, which is 3. Okay, so the formula an is equals to a1, then r n minus 1. So I'm going to put what these terms, these numbers, these values, substitute them for these variables. So an is equals to, a1 is 4, right? Dot r is 3, and n is unknown. Okay, so that's the nth term. So this one will be the general formula for the nth term for this particular series. So if I'm asked to find, why are we asked to get this formula for the nth term? If they say find the 6th term of this series, I put 6 here, and I complete the whole of this, and I get the 6th term. They say find the 7th term, I put 7 where n is here, complete everything, and get the 7th term. If they say find the 8th term, I put 8 where n is and complete everything and get the 8th term. That is why we are getting the formula for the nth term for all this series. Okay, so we're asked to find the sixth term of this geometric system sequence, the sixth term. Okay, so it's just a matter of putting 6 where n is, right? So n is equal to 6, therefore a6, right? That's the sixth term is equals to 2.5 raised to power 6 minus 1. So a sixth term is equals to 2 times 5. 6 minus 1 is 5 raised to power 5. So 5 raised to power 5. If I complete 5 raised to power 5, I'll be getting 3,125 times 2 is equals to a6. So the sixth term is 6,250. That is the sixth term of that particular sequence. Okay, so we'll quickly look at this particular past question from the IGCSE. It said a sequence has terms 2, 9, 16, 23. So the first thing you do, identify what kind of sequence. Is it an AP or a GP? AP means arithmetic progression, and GP means geometric progression. So from here, you see that difference between 9 and 2 is 7, right? Oh, so this is 7, and 16 minus 9 is 7. 23 minus 16 is also 7. So the difference is a constant known as 7. It shows that we are having an AP, arithmetic progression. So we're going to be looking for the nth term for this. A solution. Nth term is a plus n minus 1, then d. A plus n, open bracket, a plus open bracket n minus 1, the close bracket, then d. So for this case, a is what? 2, n is n, and d is 7, right? So we're going to put them in the formula. I have a is 2 plus open bracket n minus 1, then d is 7. So I can expand this. 2 plus 7 times n is 7n minus 7 times 1 is 7. Collect the like terms. This can go with this. So I have 7n minus 7 plus 2. I just change the position. So 7n minus 7 plus 2 is minus 5. So this is the nth term for that particular sequence. So therefore the 50th term will now be, you put 50 where you have n. 50th term. So this is the nth term. So 7n minus 5 is equals to 7 where I have n, I put 50 minus 5, right? Sorry. 7 where I put 50, yes, minus 5. So 7 times 50 will give us 350. I'm continuing from here. 350. 350 minus 5 will give us 345. So 345 is the 50th term of this series. So marking scheme for IGCSE is 1 mark for correct common difference. So you see that if you are doing showing your workings, always define the terms. If you say d is equal to 7, you have gotten 1 mark. 1 mark for the correct nth term. This is the correct nth term. Then 1 mark for substitution, 1 mark for final answer. So make sure you show your workings. Always show. Don't assume that the examiner knows what you are doing, or that in your mind you can just say it and jump to the next step. Show all your workings, define all your parameters, substitute properly, and get your answer. So I hope this video has been informative for you. I'd like to thank you for viewing. Please subscribe to our channel and share the videos for others to watch.